good morning or good afternoon, depends your location with this hybrid CppCon conference. The talk that I'm presenting today is about to start. It's our adventures with REST API in C++, way to make it easy, looking at different approaches. We have all participants, we have many participants that have joined, so welcome. Don't hesitate to write questions in the chat or in the Q&A system of Zoom. I might take them only at the end or between the different sections of the talk, because I'm sharing the screen and I don't have a view on the question directly at all time. But don't hesitate to post them. I reply to them in between between the sections at the end. Thank you very much. So let's start. So our adventures with REST API in C++, making it easy. Actually, we at tipi, we are building a compiler as a service, which enables to solve some problem in C and C++, and we are confronted to a lot of REST APIs. I will also come to what is a REST API or what is it in terms of web and so on. But perhaps first a small word about us, who we are and what we are doing. So we at tipi, we founded a startup the last year, and we have been working for 3 years on an algorithm that helps building C and C++, but provide it to the cloud. We have been in the past really busy with embedded C++, IoT, but also cloud services, working in our different career with my co-founder Yannick and myself. And recently, thanks to tipi, we could join the ISO-CPP.org Foundation, and we seek to be more active in this way in the future, because we have a lot to share and a lot to do, and we love C++ so much. So what I want to address in this talk, it's before I present more detail the stuff, it's what is REST at all? What is it in terms of in the web? What is it in terms of API design and so on? What is SOAP as well, and how they differ, and how this is good and it is a problem, and as well how we can write C++ REST clients nowadays, because it's something that we do often. Either as part of a cloud service, you need to gather data from another, or as a client, like an IoT device or so. There is a lot of HTTP or REST communication that is being done. And I'm going to show different approach that you can take to solve this problem. But first, before I go to this, perhaps I can tell some of the 3 problems that we see with C++, and REST client being a 4th one. So at tipi, we are trying to solve these 3 problems. The first one is code reuse. And the tipi is a tool that allows reusing any code, any libraries. So, for example, a REST library or a library for HTTP calls. What we have done is we've wrote an algorithm to defragment the C++ ecosystem so that you can easily reuse any library without waiting on the package maintainer to write anything like a package script or so. We can just reuse any code that is out there on the internet. And for this, we use REST APIs to access the different services to find the code and to download it. The other thing is, in C and C++, it's pretty hard to set up an environment to start working. Before, we have always the differences of targeting either Windows, Linux, macOS, or special systems, or even special instruction set. So at tipi, we also have you covered for environments. That means at this time we have the code base here that we see, but it's dependent on a lot of stuff. And this we provide with environment files. And the last thing is we scan the code and we improve the parallelity of the builds so that developers can take less coffee and write more REST APIs. So this is what we are doing at tipi. So there is an ad that is coming now. Sorry for this. So if you want to try it out, you can go on tipi.build and enter the activation code tipi launch CppCon 2021. This allows you to try out our cloud builds on our super algorithm. We are rolling out feature one after another. We are in open beta, so there is still a lot that will improve, but we are happy if you can try and come, and perhaps you can as well help us with REST after that. So REST APIs. In C and C++, it's a language that is thought for system programming, but a lot of people use it for a lot more stuff. And we would like to write everything in C++ if we could. But most of the time, there are some missing toolings, or there are missing features in terms of support for what the web is doing at the moment, and it's not easy to cope up. So we had the problem of accessing REST services that we wrote in C++ as well, but this is another story. Or even in JavaScript as well, we have a bit of JavaScript. And REST is, after the Wikipedia definition, is it's named representational state transfer, and it's a software architectural style. And it's a style, and this is really important. It's not a standard. It was created actually to help the World Wide Web grow and to diminishes the barrier at entries. As a TP, we are trying to diminish the barrier at entry of C++ by providing everything you need to compile, to run, to type. They tried to define a set of architecture that helps to build software, but is actually easy to interconnect. And our take on REST is that actually you access resources using URIs. URIs, it's a uniform resource indicator or locator. And each resources are entities, and they are manipulated with CRUD operations. And this is made with hypertext representation. This can be JSON, XML, or just text as well. And the goal of it was a strong decoupling between client and server. The goal was actually to allow for the web to scale and to improve greatly and fast without any common vendors telling how things should be done. And this is like pretty nice if you have to just access to one service, but this is as written an anarchic scalability solution. It is really hard if you are the person writing both sides, because you just are repeating yourself all the time, writing the server, writing the client. There are no like automated tooling to do stuff. And this is pretty annoying when you have to modify the REST API on the server because you notice the bug or you're missing an information, then you have to go back to the client, write it yourself. And this is nice to interoperate with people you don't know, but if you are building your API REST yourself, then it's pretty difficult to maintain, given the size of the API. So we take a little example. The typical example for REST APIs nowadays is the pet store. It's just an HTTP RESTful representation of a small pet store where you can buy cats or dogs and so. And with the CRUD operation that we spoke before on the entities, for example, be it on a pet that is in the catalog, for example, it will be create with post, modify with other update, include with pet, delete with delete, and accessing it is with get. This is HTTP methods. We come to HTTP as well, because actually REST is a style, and the most common used style for REST is using it over HTTP. And nowadays, what is also really typical is having REST services with JSON, hypertext transfers. There is also a lot of XML, but due to the nature of JavaScript that is in the browser, most of the web services nowadays have a JSON endpoint, or it's also the preferred solution, if we can say. So how does it look like? If we take a look at the API for the pet store, I can just show you, for example, the documentation of the API. This is something that we will come back on it later, but it presents the OpenAPI with the different options. And for example, on the pet entity, on the pet URI, you can modify the pet entities by either giving the pet ID that you want to get, or that you want to update, or that you want to create. And we'll take a look how to implement that in C++ now, just as of today, what is the easiest path for this. So the goal is that the C++ application sends over the wire over an HTTP connection. That means a TCP/IP connection. But nowadays it's also changing. There are quick and so on protocols, but I won't dig into this detail right now. And the goal is to post like the creation of a dog with the ID 1, for example. So an HTTP request is just text, as I said. It's a style. So HTTP is a standard, but it's also pretty loose on how it is structured. You have the headers at the beginning, and then you have two end line, and then you have the body. And the goal to send that in C++, the way to send that in C++, the most traditional would be to implement a post, a client, and to write that as someone would like to someone as anyone would like to do. But it's interesting if we take a use case, because at TP, when we build something, we always try to find the real use cases for users, and we don't just blind in the work. So what we could use the Bedstore for? Actually, at TP we have an official cat, and I would like it to be in the Bedstore so that it can be featured and can be seen. So just to show the TP cat, it's our cat that you have at the office is named Haskell because we wanted a pure functional cat. But we're still C++ developers, and the goal is to put his picture in the Bedstore of the OpenAPI TP. So, taking a simple example, so if we want to write that, the first thing that we need to figure out is how data are transferred over the wire. Because accessing the URI is one thing, but then you need to write something on this request, and you need to act on it. So one of the typical way to serialize in C and C++ JSON, if it's JSON, we'll check that. So on the post, if we want to create the Haskell cat on the Bedstore, we can see that I have an example already written. It's possible to write it in JSON. And if I not trying to move the window here, okay. If I try to execute this command, and what happens is that the API v3 pet is called, and we see that different type are given. Here I accept application XML, which is not what I think I want, and I create and I send a JSON on the top. So we have now gotten back an XML. We can ask for asking a JSON. So because we can ask for accepting given data type, and in C++ we will only focus on JSON. We won't go on XML, but it's the same principle. So here I created another Haskell, and it sent me back the response body. So we need to implement something that serializes that in C++. So the most typical way of doing things is using a library, which is made for JSON. There is a super nice one, which is named the Enloman JSON. And then you can write functions that transform your data type to JSON and back. So let's look at this first. So if I want to use the library with TP, I don't need to, this is not the right one, okay. Here, if I want to use the library in TP, I can simply include it, and TP will either look in the depth file or help generate it to find the right library. And this will give you like GitHub path. And if I go on GitHub, for example, to check out github.com, JSON, I have here a library that I see can help me to write JSON for more than C++, and I would like to use it. So I can either go on the integrations here and try to understand how I have to install things and so, or I can just say, okay, I don't care, I just want to use the code. So let's copy paste the name of the library and put it in TP, and we will have it at this result. Okay, so So we are taking just the last version, and we have defined a pet structure to represent our pet from the API. And then we have written the element JSON functions that are selected automatically from element ADL resolution. If the to JSON from JSON is in the same namespace, the advanced dependent lookup will find the to JSON and from JSON for these types. And then, as you can see, I use a library that is a library from the TP team. It's 66H. It is a library that works for web queries, be it for WebAssembly targets, but you can make web queries in WebAssembly from the browser or from Node.js, for instance. Or if you want to make web queries to any other resources, it is a library which is meant to be using asynchronous I/O by default, so that you can use it in context like browsers and so, but it works on native platforms as well. So here I say what you had before, that I accept the application JSON and that converted with application JSON, and I give in the URL of the service that I want to access. So I want to access the pet entities. And here I take the JSON cat that I generated before with nLeman. And when I did this assignment, the function to JSON was called, and a JSON object in the nLeman type was created. And then I can see if that works. So let's build that for my local machine. So yeah, macOS, I'm on Mac, so I'm building for Mac now. Oh, there is a mistake in the output here. So I broke something. Like, oh yeah, it's better like this. Okay, so let's build it again. Okay, the dependencies are pulled, and my traditional REST client is being written. So if I start build macOS bin traditional, then I can see if I draw the screen, so it was built, and I can see the cat in JSON. So the to JSON is working, and I even got a reply 200. So in HTTP, it's the reason for success. So here it's the output, reply 200, and we got back the input that we gave to confirm that the instance was created. So this is in itself pretty easy, but what happens if someone adds fields? You need to maintain these things. And what if the API changes? There's a lot of topics. And we had a customer that has a gigantic code base with TP and with REST. And this customer, he had exactly this bug, is that he wrote a lot of code like this. There were like tons of files with 2,000 lines where it was only to and from JSON written from humans. At best, it was in some places generated, but some of it was just modified. And I don't know if you can spot the bug here. Not being live, I cannot see hand raised, but if you can spot the bug, you are welcome to write it in the chat, or if you have line 8. Okay, Louis Thomas is saying line 8. Yeah. The name is, the address is written to the name, Randy Stich as well. So Louis Thomas and Randy Stich, oh, okay. So we are writing the name instead of the address. And these are things that happens really often when you write stuff like this, when you're repeating yourself. It's one of the basic concept in software development. It was even my first patch to Boost.Fusion, doing things so that it's not repeated because it's the dry concept. And so the bug was caught here. So you could fix it, but in general, it might happen again. And what could we do to avoid that? In C++, there are sadly no serialization, reflection mechanism at the moment, or there are little reflection mechanism, but there are the possibility to generate compile time information or compile time reflection information yourself with macros. There are different. Nowadays, there are Boost.ANA that is doing this as well. And the element JSON, I just saw before the talk that they also have this facility. So there is different different options, but you can do this, like registering the different fields and generate the JSON out of it. So this is pretty nice, and I don't want to go in the details, but there is one big risk with it, is that you need to serialize something that is a standard C++ keyword, or that doesn't fit in the C++ authorized identifiers, but might be authorized in JSON. For example, something starting with a number. I see in the chat that someone says, sure, Google Protobuf can go to and from JSON. This is something I believe with Google Protobuf is more like you generate code and you get back such automatic generator for this. I'm not sure if they can generate JSON out of the box, but it's something that you need to do as an additional step in your program, in your process. So you need to add something during the build, some option to some programs that run after your build or before your build to generate files. And this is something that I think in C and C++, we have a lot of compile time metaprogrammers that are out there we try to avoid. So that root code is enough in itself. But we'll come to this point. So this is like a problem. So what could we do for this to make it better? I think there is a way to make that way better is with C++20. Actually, C++20 enables a lot of things. So, and this is where I start with my magic in the talk. I go back to a little less magic, and then I come back with real magic at the end. So in C++, you have class template argument deductions for context for variable now, and so in template parameter lists. And you can therefore use any context type inside a template parameter list. You have structured bindings since C++ 17. You can easily mix these three things to avoid repeating yourselves, actually. And I think during the conference, I was at different talk so remotely, and I saw a lot of stuff using one of the key feature or the key types that I use in this context. And this is the fixed string. So I come to it, but if we look at how we could do reflection in C++ without having reflections, so that we don't need to have this macro that states the different fields, then it's actually possible. Some of my slides have got a little problem. Let me fix this. They have hidden the text, which is not good. It's because I'm giving credit, and it's not. It's bad if text is hidden on your document. So, and there is some really smart in C and C++ community. Is named Anthony Polukin, and he wrote already at the time of C++14 a library that is named Boost.Fusion, which brings the Boost.Fusion basic set of features or the Boost.ANA basic set of features for reflecting over a type. And the goal of PFR is that it can take any types that is a simple aggregate, and it can read out all the fields and generate a tuple out of it. So today that you can iterate over the field, and that you can access the field over an index, or so that you can reflect over the type. So this will give us the possibility to have any types and to access any fields by value, and to be able to serialize things. This is a pretty nice library. So it's the two things it does. It's actually it uses aggregates initialization. in a concept or in a S3NA context to check if it can instantiate some type with one field, with two fields, and then it can destructure it to two, for example, and then it can iterate over that. So these are us iterating, which is pretty cool. I know why the text was broken. Okay. If we, I don't want to dig into much details because there is a good explanation in the library, but we are going to use that and to combine it, because what is good in C++ is when you can combine features. So what happens when you combine structured bindings and detection of field count with aggregate initialization and static string or fixed string that we saw in the conference a lot of time. Actually, it gives you the ability to write something like this without repeating yourself, which allows you to serialize anything. And it also allows you, if you want, to have different names from the identifier. So let's dig into that. So this is one of the key pieces of the REST support that we need in the rest of the talk. So here I have this pre-JSON key thing. This pre-JSON key thing, I'm someone really nasty. I did it with a macro. I like macro actually. It's a really good tool to extend the language a bit. But we can look at the macro in itself. It's not much. It's a lot more C++ reward macro actually. Let's look in the libraries that were installed from the TP installs everything in a sysroot there. So here actually we have this pre-JSON key macro, and it's just a thing that takes the name and stringifies it in C++. When you do in a macro context, you use the hashtag operator or let's say the sharp here. When you use it, you can concatenate things and make things to strings. So we are generating a compile time string like a const char that you pass as a non-type template argument to key value pair, and we pass as well the type that we want. And this is like you could have written as well here in C pre-JSON key. It would have been possible to write. Let's skip that. For the example of we had before, you could have public as a name that would be serialized then in JSON, for example, and from type int, and the name var would be then public underscore, because it's not possible to write public in C++. And so this way you are serializing as well a public field with the name public here. And this works. You can call now the API without the to JSON and from JSON. So the file is now 34 lines. Before it was 42. So 10 lines code less to maintain. We don't have any more these big functions to maintain, which are a bit messy. And if I build this one as well locally, normally. Oh yeah, it needs C++20. Sorry, this was no, not really smart. So let's build it with a TP version that can C++20. If you want, you can try it. It's almost available. We have a C++20 supporter as the compiler supports them naturally, but it's pretty good as of today. And we just bought the program, and we can start it again. Okay, for C++20 and Magic. And here we had the request done. I didn't save the change with public, so I will save it and try it out if it works. Just combine the commands so that you don't need to repeat them if that compiles. So different libraries are getting pulled because we needed this pre-JSON, but it's from us. we provide like a general JSON library for serialization and so. And if we're happy, it compiles. Otherwise, I made a mistake. Oh yeah, it won't compile because I don't initialize the value here. So let's put it there as well, like but public to 1. We had a Boolean before, so well, I'm gonna make a bool out of it. So true. I don't think I repeated myself in this code. Ah, I did repeat myself. Okay. So remove the repetition. That would be easier. And let's check it if it works. It's better if it works. Spinning a bit. And here, while we wait for it to compile with the change, we can look at how it is implemented. So what I did is that I took the code from the presentation from Jason Turner, which was named Context for All the Things, that was made in 2017, I think. And I extended the feature of the library so that we can use the static string in different contexts, and that we can do a lot more regarding REST. And this we will release at the end of the talk. It will be in tipi.build on GitHub, and it allows you to do a lot of things like having name types that are strings that you can match at runtime and compile time. And it's fairly easy actually. Is you have the key value pair is just this non-type template argument that uses in static string a compile time argument deduction guide. A deduction guide to deduct what, when I give in the little quoted text here, when I give in here public, actually here it's a conchar array from a given size, and this can be deduced to be instantiated to a type that is CX static string that we saw in the conference many times, but just to give you what is the CTAD thing that we use is like, it should be in there. So it just go around a bit. So let's go there. Okay. So pretty back. It's pretty low on the thing. I'm a bit astonished. I don't find it right now. So the string. Okay, where is the strict? Here is the strict. So it's at the end of the class. Here we should have something like n-1. I don't find it right. Oh, it's the wrong. I opened the wrong type. Actually, that's why I didn't find it. Sorry. It's the autocompletion of the. Okay, here is the type that we all know. By default, it generates a gigantic one to be able to have runtime static strings that are able to be compile time fit. Shrink to fit to the size that it would have in compile time. And it uses this template deduction guide so that you can write 6 key value pair public, and that it instantiates a key value pair that actually has a static string. It uses this deduction guide to generate it actually, or this one on 977. I look at chat if there are any questions right now. Okay. Okay, there was a question about compilation times. Okay, yeah, it's we have a lot of things running at the moment, so perhaps it's that's why with a Zoom presentation and so. So this was like the little bit of magic that we could allow with CppCon just by reusing a bit of the different features that are available around, like disaggregated initialization and so on. In the end, the JSON generation, if we look deeply into it, to have the full view, it's pretty easy. When you look at pre-JSON, we have a class that is named JSONizer, and what it does is that it selects some operators to convert the value, and when it comes to a non-adapted struct, that is something that has not compile time reflection like we had with Boost.Fusion adapt also, but it's just a struct, then it simply use the Boost.FR mechanism that we explained before to iterate over the different fields as if it was like it's a tuple. And for this we use Boostana to iterate over tuples because it's a pretty easy. And then we simply have a special handler that generates the JSON for this specific key value pair type that we have seen. So now we can have compile time strings and strings to that are on types that can be reflected. So here you have the implementation that I presented inside the code. It's fairly easy. As we saw, we can come back to it in the question section. And now that you can serialize things, that you can do stuff, it would be nice actually if we didn't have to ask the developer of the API or look for changes and call, hey, did you change something? Did I need to change something in my code? If it would be possible to know before going in production that the API changed and that you need to adapt stuff. And for this, actually, there was another standard that was pretty trendy in the past. It might still be used. I just never encountered anymore for like 5 years or so. It's really different from REST because REST is a style. And SOAP is like a standardized protocol that comes with automated tooling that generates code, that has defined XML types and so on. It makes it pretty hard to maintain a code base based on it because it's based on support tool and it generates everything automatically, but it's not easy. But it has the advantage if someone changes the definition of the server, that you know it when you build the client. This is really nice. And the question is, what can we do so that we don't need to do what we did right now, like deserializing manually, having we need a test suite to check that the API changed. What can we do to have this open API thing in C++? So it's possible to do open API in C++. There are support for it. And one of the main support that is available is from the official OpenAPI team. And this is something that I want to quote Conway's law on it, is that when you build a client on a server, there is one implementation for the server and one implementation for the client, while most of the interfaces are shared, and this one could be shared. But the point that it's not the same people that are doing it, then it's implemented twice. So the state of this tooling that is named OpenAPI generator is not that nice in terms of C++, but we can still look at it. So we can go on OpenAPI generator C++, and we find like a tool on GitHub, and this tool actually allows to generate for a lot of languages, as we can see. C++ is in there, C++, and there are like some support for libraries. And the one that is the less bound to a given platform is actually, or to a given set of settings, is the CPP REST SDK.
So, excuse me.
Yes.
You are actually sharing your presentation and not your Firefox upload.
Oh, okay. Sorry. I thank you very much. So code generation, generating REST clients with OpenAPI. So OpenAPI, it's on one hand this tool. On the other hand, it's a configuration that specifies how the endpoint looks like. The pet store is one of the most known examples for OpenAPI. And it's made of a JSON or YAML configuration, which outputs this automatically because programmatically we know there is a pet, post endpoint, and so on. And the JSON looks actually like this if we open it in a separate tab, and we print it like this. Then it contains the description, where the server is located, what is the URL to use to access it, and the different path, like we saw before pet, and we use pet post, which is here. And so this is like to add a new pet to the store, as we saw, and you can use it to generate code. So it's possible in C++ to generate code for this. There are tooling for that. And what you need to do is you need to write an OpenAPI generator YAML that points to the pet store JSON. And this pet store JSON is the one we just saw. I just reduced it for the sake of simplicity. I just let the pet post in it. And when I want to use it, I can ask TP to provide me for the tool for it, because TP provides all what you need to build. And it generates the OpenAPI code, which is then generated in this pet stuffing. But it generates, like, as we saw, we have one little pet request, and we have like the world that was generated. And in this world, there are finally still a pet, and there are like a JSON serializer that is used from the library underlying. And there are a lot of code that comes in there that you don't want to have in your code base, that is not ready to be built. There are stuff to do, to modify, to make it build. I just generated it. I would expect that there will be enough code to build it. So let's try it out, but I don't think it will. Let's try that out. So TP tries its best to compile it by looking for the different stuffs in there, but missing some stuff that were not pulled in on. So it's a possibility. I think in C+20 we can do better than generating this code that is not necessarily up to date and that has many problems. Mainly we use this OpenAPI generator in our APIs, but we saw as of today that when you change a root or something, it generates types with numbers. When you, for example, for the status code 200, it generates type with _200, and it might sometimes mix types, and it might still compile because the type are authorizing the construction of the can be constructed from the type that you give, but it's no more the same. And then you have issues at runtime, which is really sad for something that we have a configuration that you could use at compile time. So enough of this generator and of this stuff that generates code that nobody wants to use, or that are forced to use. We are forced to use because we didn't have that before, but now we have something. So we are switching slowly to it. And it's the goal that we have there is having a compile error if the API of the server changes, if the data model changes. We have then resource URI that want to check if we access some endpoint that are not supported, we should have an error. We should not allow it. And we still would like to have autocompletion despite generating types at compile time and not having the generated code, so that a developer can still just use this editor and autocomplete things. So what we do is we take the work that Jason Turner did and Ben Dean, I think, did together for the concept of all the thing. They wrote back then a JSON parser for the back then support of context. And we augment it so that we can build an OpenAPI parser at compile time that generate types that can be used to generate the serialization types that we saw before, so that we can, in the end, build something that is that looks like this. And here I just got shortened the JSON that we had. And what I want first, it will be to be able to call with compile time strings as a non-type template argument that I would pass to my client, and that I can give a tuple. And when I make a mistake in name or in the name of the argument, that it give me a compile time error that it's not in the OpenAPI specification and that this type is not supported. And then we will move a bit further to generate even like types. But this is like just an added sugar on it. So if I take this this example, I will just come out to the second one. I can actually call this add pet automatically. For this, I have an HPP file that contains the JSON of the OpenAPI. It can be of any size; it's not limited. And I have here in there my different config, and most notably the path pet, that is a post request to create a pet store, as we saw, and that reference the schema pet. And the schema pet is below here. The different fields that are required for the pet to be accepted online, and what type it has. For example, ID is an integer, name is a string, and so on. So how do we do that? So the implementation is early, but it works. If I save that one and I just run it like this, then here I have everything correct, so it should just work, and it should just build as usual. And I can normally call add pet with an ID 43, with the cat name Haskell, and with the PNG image that we saw before. To do that, actually, when I move to call operation, I actually need to find out in the JSON the add pet configuration, like finding the path specification for the operation ID add pet. And if you look at the call operation function, what it does is that it calls with the same static string that we had before as a non-template type argument, so that everything happens at compile time. The full parsing of the parsing of the JSON happens here at compile time. When I do create operation caller, what happens is that I use this. I use the JSON that is in this separate file in this static const expr option OpenAPI JSON. I use it actually to access the post, for example, key. So I can go down to the post key of the schema of the path that is named pet, for example. That is named that is named add pet, sorry, for the opportunity that is named add pet. So I found the key here with the create operation caller call, and then I find the request body that is expected, or the response body that is expected for the code. Oh, but I'm showing off. That is needed for this call. That means component schema pet, but I'm showing again the wrong code because it's so big here that I didn't recognize it. Okay. So what I did here is access path, and inside path I look for the operation ID that is named after the compile time key. So it's at compile time, but I can still use nice for loop over JSON structure and do an if. This is like, and then generate another JSON value that is compile time because it's just a part of the file in there that is a C++ context bar. And then I can access the different keys, which if I look at the code, generated me like a way to call this add pet function. And when I call the dinner that was generated out of it, I have this little cat that has been created. I could reply 200 again. And it was generated most of the code completely at compile time. The only thing that happens at runtime is the actual call to the network, actual filling the values here and calling on the network. But the rest is all const expert or const table. So if we look at the function call operation again, we can see that it relies on this create operation color that comes back to the const expert, and this create operation color is a const table. So if I go back there, you can see here the const table keyword, which ensure that we are not doing anything at runtime there. And I use that to bring back the schema, and then the schema is parsed. And for the schema, then we use a little bit of template metaprogramming to iterate over the different types that we got from the schema. Because you cannot iterate, or so far I didn't find a way to make a for loop in context per context that brings you an index that is at a compile time value. You can make a for loop and generate a compile time value and return it back, but you cannot like make a for size TE and use this E as a compile time value. But what you can do is that you can get the count of things, and then when you get the count of things, you can actually, when you get the count of all the arguments, we have a special concept of function which says get argument counts. For example, get argument counts will get all counts for what is in pet, all properties that are in pet, for example. So get argument counts, what it will do is it will go in the JSON at compile time, find the properties key, and give the count back of how much properties were in there. And then what we do to use this information is we use this arglist count here below in the argument list that you have for the path, where we take the operation ID that is a const expert. We transform it to a type, to a string that is actually a type in C++, so that we can use it in the context of a template metaprogram as we are used to with Boost.MP11, for example. And we can then find out and transform for all the count of arguments. We can then call for each of these arguments the expected arg4t that calls actually template meta function as well, which brings you back actually the argument name out of the JSON. That means it will give you ID, for example, it first. And this ID will come back as a static string that is bigger than the one that you will type when you write it directly in code. So we shrink it at compile time to just until the /0. And then we can use this name to generate the key value pair that we have seen before. That is made of the type and of the name. The only catch with this technique is that the type here comes as integer, for example. So what gets written in there when the template is instantiated is it's a t-string integer that comes here. And this is not a valid C++ type. So what we did to support the type of OpenAPI is that we have a simple technique that I think there was a blog post at the beginning of the conference about it as well. And this is a simple tag type that you can use to say, okay, name type integer is of type int, for example. And name type Boolean is bool, and so on. And then you can map the type that are available in your JSON and use them. And what is cool is regarding a requirement having a compile time error if we do a mistake in the fields that we use is, for example, if I make name underscore, which is not supported in this context, I can it always pulls the latest libraries to be sure. I can actually access, I will get an error. I didn't get an error. I didn't save the file. Sorry. Let's save the file again. And let's repull all the libraries again. And what happens is that I get here compile time error, which in GCC is pretty nice. In Clang on MSVC, it's still like strings are represented as ints separated by commas. But I think this will improve over time. And even though you get the information, you are mistyping something. And we don't want to force the people to use this signature. This is just like an intermediate signature where you don't have any code generation at all. So here we have the error. We see that actually for the operation at pet, there was no conversion that were possible from this string, which if you take it in ASCII, you take the over in ASCII, it's N is 110, A is 97, sorry. So you have NAME here with the /0 at the end. And here you have NAME underscore with the 95 on the /0 at the end. So what it's giving you for information is that you mistype this one, and then you can fix it and it will compile again. The other thing that people would like to is writing code directly without this complex static string. On this, we can use our tool to output we can generate at compile time the calls that are necessary to generate like the types that you want. For example, pet, it's something in the schema. We would like to have it in the schema. So what we can do is we can iterate over the information at const_expr and generate out of it at the end a stdc out that outputs just a little header that you could use, like JavaScript typings, if you know it, to give you autocompletion for the stuff that actually happens at compile time. So if I take my example back here, and I just take I don't want to make the call directly. I will just print the code out. So what I do is that I take a poor person meta class. That would be cool to have meta class to do that, but we don't have them yet. And the poor person meta class is just the all operation thing is we look at all operation is a transformation from all the operations that you could parse in the JSON at compile time that are generated, and we transform them inside generate operation T that will at instantiation print out the code that we could include to have autocompletion in your code. And to do that, we just use here this all operation. We transform it to MP inherit. So it's a big class that instantiates all operations. And if I build this one, always on my local PC for the moment, not with a remote compiler, but still I have all what I need to build my software. I can then get as output the code that I will need to include in the C++ directly. So let's wait for it. Oh, I didn't save it. Oh, yeah. Which is stupid. Okay. And what will be generated out of this call is this code. It will generate what we saw before with the different type that we want to support, with this name type that we spoke about, and the @pet function that is just again Boost.Fusion come back to the rescue, which is just a wrapper for the actual compile time const_expr and template meta program that generates the call actually. And this is just like a poor man meta class, like one may say, which just outputs the struct that you will need to use to have the autocompletion of the code and to have like a code that is more natural than directly passing key value currency. Okay, so we are about to finish. So if you want to use a really cool compiler as a service and have your build increased by 10x, and have dependency automatically pulled and have everything done, don't hesitate to join Tipi. There is an activation code. If you give it in there, we provide you with build minutes on the cloud. Don't hesitate to do it, because we are building all these cool tools in open source now, and we are launching this REST API will be available as well. We have a blog post about it, and it will be on GitHub on tipi.build OpenAPI CPP, and there will be a link in the slides that I share at the end. And don't hesitate to try it out. Thank you very much. If there are any questions, I'm happy to take them in there, or I look at the Q&A, and we can possibly also move into Gather Town afterwards.